13.5. All we're doing right here is notice that this is now set equal to what?
0.
So we're going to factor and then set each of our factors equal to 0. Okay? So what method would we need to do in order to factor example 1? Good. So let's do that. Over by 2, we get x squared minus 7x minus what? 30 equals 0. And so we are looking for two numbers that multiply to be negative 30 and add to be negative 7. Very good. It is negative 10 and 3. So we have x minus 10 and x minus 3. Those multiply. Oh, wait. No, that doesn't work. Thank you. So those multiply to be a negative 30 and add to be negative 7. See how I double checked myself and I saw that there was something wrong? Okay, so always double check. Good. So anytime we go over, we have to go under. So we go under by 2 and you reduce. Okay. So we get x minus 5. And then over here, since this doesn't reduce, what do I do?
2x plus 3.
Good. You bring your bottoms up and we get 2x plus 3. Okay, and then your last step is to set each of the factors equal to 0. So x minus 5 equals 0, 2x plus 3 equals 0, and we end up getting x equals 5. Do I need to work this out? And this is going to be x equals negative 3 over 2. And there are your two answers. Okay, questions? Okay, example 2. What do you notice about example 2? What is it supposed to equal? 0. So what are you going to do?
Subtract it.
Right, and you're going to have to multiply this out. Do you notice this? Something about this? Very good. So therefore, do I even really need to do like my box and multiply it all out? It's going to be x squared what? Well, let's just do this first. This is going to end up being x squared what? Minus 16 equals 15x. And then let's go ahead and move over the 15x. So we'll subtract 15x to both sides. And we end up with x squared minus 15x minus 16 equals 0. Good. So our 16 is our multiplication number. Our negative 15 is our adding number. So what numbers did you guys say? Good. And we set those equal to 0. And yes, she's here. And what do I get? Very good. So positive 16 and negative 1. Yes, because it always goes in descending order. So you have your x squared term, and then your plain x term, and then your number without an x. Okay? And when it's in that order, your middle numbers you're adding, and your last numbers you're multiplying. Okay, so try example 3 on your own. Okay, what's the first step on this problem? Subtract 14x. Because it needs to be set equal to 0. We write this in descending order. So, x to the third comes first, minus 5x squared comes second, minus 14x equals 0. So do we see how this is x to the third, x to the second, x to the first? Okay, now what can I do first on this problem?
What?
Good, there's a GCF of an x. So I'm going to take out an x, and I get x squared minus 5x minus 14 equals 0. Is there anything that multiplies to be negative 14 and adds to be negative 5? Very good. So we get x, and then we have x minus 7 and x plus 2. Okay, double check them. Negative 7 times 2 is negative 14, and when we add them together, it equals negative 5. So then we set each of these factors equal to 0, x equals 0, x minus 7 equals 0, and x plus 2 equals 0. And when we solve those, this is just x equals 0, x equals 7, and x equals negative 2. Well, x equals 0, that just means that one of your answers is 0. There just wasn't anything more to solve. Now, if there was a number in front, remember if we factored out a number and you had like 3 equals 0, that doesn't make any sense. We'd cancel it out.
Okay.
But x equals 0, 0 is a number and it'll work.
Okay.
Other questions? Okay, let's move on. Okay, what do you think you would do first on example 4? Very good, get rid of the fractions. And in order to get rid of the fractions, we need to multiply by the, no, least common denominator. Okay, what would be my LCD on this problem? Very good. So my LCD is x times x plus 6. So I'm writing that to every problem, x times x plus 6. Or every term. I don't know what I said there. So I always write it next to every single term because I just want to make sure I don't forget to multiply something. Okay, the whole purpose of doing this is to eliminate your denominators, okay? And so if you don't eliminate one, then you did something wrong, okay? So on the first term, what happens? Good, the x's cancel out. So I have 4 times x plus 6. What is 4 times x plus 6? Okay, 4x plus 24. Are we all okay with that? Yeah? Okay, next term, what happens? Our x plus 6 cancels out, and I have x times x, which makes? Good. So I have plus x squared equals. This last one I have 1x times x plus 6, which is? Good. X squared plus 6x. All right, so now in order to factor, what do we need to do? Get them all on the same side so it's equal to 0. Well, when I move my x squared, what happens? They cancel out. So the x squareds are gone. So I'm going to go ahead and, if you notice now, if I were to rewrite this, I have 4x plus 24 equals 6x. Am I going to end up factoring this one? No, why not? There's no x squared term. So all we're going to do is solve for x. So what should I do then? Very good. Subtract 4x. So now I have 24 equals 2x, and then my last step would be to do what? Good. Divide by 2. And so x equals 12. Okay. Are we good? Yes? Okay, so this next part on our trig is to determine the missing side length. So if this is 60, this one over here has to be what? 30. Okay, if you go back in your notes, across from the 60 degree is your what? Okay, across from your 30 is your A. Across from your, this should not have had a 7 here. I don't know. I think I made an error here. Okay, sorry. So this is my A. Across from my 90 is my 2A. And across from my 60 is my A root 3. Okay, so cross out that 7. Sorry about that. Okay, so this is the only side I have, right? So what you do is, depending on what it is, you set that as an equation. So I would write A root 3 equals 9 root 3. And I want to solve for A. So how do I get A by itself? Very good. We would divide by root 3 to both sides. These cancel, so I end up with A equaling 9. Okay? So that means that my missing side lengths are what? Good. So I'd come over here and I'd write this as a 9 and this as an 18. Okay, so on example 6, it's a 45, 45, 90. So on my 45, 45, 90, what are my different sides? Okay, so it goes A, and then A root 2. So the only side that I have is this side right here, right? So we write this as an equation. I write A root 2 equals 8. How do I get A by itself? Divide by root 2. Okay, can I have a root in the denominator? So what do I do to get rid of the root in the denominator? Good. We multiply by root 2 to both the top and the bottom. So I end up getting 8 root 2 over 2. Can that reduce? Yes. What does it reduce to? 4 root 2. So that means that A equals 4 root 2. Therefore, each of these sides are 4 root 2 because they're both A's. Do you see how you figure out whatever this side is and what the formula is, and you set it equal to solve for your variable? Does that kind of make sense? Do you guys understand making this an equation? Okay. All right, and that's it. Do you have any questions?